In this lesson, we're going to talk about finding area of rectangles and parallelograms. Let me begin by telling you what area is. The area of a figure is the number of unit squares needed to cover the figure. Another way to say that would be square units. Unit squares, square units. So what exactly is a square unit? Because sometimes we don't really know what that is. Well, if you had a square and it was 1 inch wide and 1 inch tall, the area of that would be that is 1 square inch. Right there. That is 1 square inch. So that is a square unit of square inches. Now we have different units, right, of linear measure. There are inches and feet, centimeters, meters, kilometers, miles. Okay, they all measure linear distance. So this is just one example, a square inch. I also drew you an actual square foot. So this is 1 foot by 1 foot. So this is a square foot. Now because it's a foot, it's also 12 inches. So this square unit, we use square feet for things like purchasing carpet. We purchase carpeting by the square foot. Sometimes we purchase tile by the square foot. Sometimes maybe land for a building is purchased by the square foot. I don't know. But either way, this is what a square foot looks like. So if you were trying to find the area of a room to purchase carpeting, you would measure how many square feet are in the room, and then you would know how much you have to pay total. I made a note for you here that I think is really cool. 1 square foot has an area of 1 square foot. So the area that this takes up is 1 square foot. But also, this space right here also has an area of 144 square inches because it would take 144 of these to cover this. So depending on the units we're using, the area will change. Well, the area doesn't change. The measurement of that area will change. The numbers we use to describe that area will change. Let me be specific. So to find the area of a rectangle, we find the number of square units that it takes to cover the rectangle. Here is a rectangle that I've broken up into square units. This rectangle has a base of 5 units, so it's 5 units wide, or long, I guess, and it's 3 units tall. So the area of this rectangle is 15 square units. If you were to count each of these square units, you would notice there are 15 of them. And so the reason we say that it has the area of 15 square units is because it takes 15 square units to cover that rectangle completely. Now it just happens to be that because this is a whole number and this is a whole number, that there are an exact number of square units in there. But area is not going to always be a perfect whole number. Not always. Because when you measure a room, is it an exact perfect number of feet? No, it might be 15.5 feet long. So you have to factor that in. Sometimes it's not going to be perfect. So I wanted you to know that rational number areas are perfectly acceptable. Just make sure you check the mathematics. And I want you to also check here. Have a look at this, and I told you that it's 15 square units because I've drawn them out and we've counted them, but notice the relationship between the area of the rectangle and the lengths of its sides. If it's 5 units wide and 3 units tall, and then 15 square units total, that's a clear multiplicative relationship, isn't it? Okay? That leads us to our formula. And you are going to have quite a few formulas for finding area of different shapes, but if you understand the concept, these formulas build off of one another. So the area of the rectangle is going to be A equals B times H, and these are both lowercase, and this is capitalized. Please keep it that way. Now the area of a rectangle is the product of, meaning you're multiplying these two because they're 2 variables next to each other, which have a meaning, the product of its base, B, and height, H. And I make a note that you must remember throughout this entire lesson that the height of a polygon is always perpendicular to the base. So here, if the rectangle is laying this way, this would be the base and this would be the height. But if it turned this way, this could be the base and this could be the height. The cool thing about a rectangle is if you are multiplying the base by the height, it doesn't really matter which one's the base and which one's the height, because you could turn that rectangle. That's where the commutative property, again, comes into play. Whoop. So, if I asked you to find the area of this rectangle, 8 centimeters by 2 centimeters, I would first write the formula. I would then fill in the values where I know them. I know the base is 8, and I know the height is 2. I know 8 times 2 is 16, so I can say that the area of this rectangle is 16 centimeters squared because it's square units. Okay? The notation is important, centimeters squared. This is the difference between 16 centimeters straight and 16 square unit centimeters. Okay? Here is a little bit of problem solving for you. Bethany and her dad are planting a garden that is rectangular. The area of the garden is 1,080 feet squared, so that's the area, and the width is 24 feet. What is the length of the garden? So this is interesting because it's not asking us to find area. It's assuming we know what area is. It says the area is 1,080 feet squared, and the width is 24 feet. So I drew a picture, and it's obviously not perfect, right? I drew a picture of this scenario so I could visualize what's going on. I know the formula is A equals B times H, where the area equals the base length times the height length. So I don't know the base length, but I do know the height is 24, and I know the total area is 1,080. I substitute these numbers in for where they go, and then I solve using my equation solving skills for the unknown amount. So that's 1,080 equals the base, which I said is B, times the height, which is 24. Now again, these are multiplied, so the opposite of multiplication is division. I will divide by 24 on both sides to maintain equality. This leaves me with 1B equals, now 1,080 divided by 24. I'll say 24 times 4. So that's going to give me 16,896. So that's 496, subtract, that's 2 and 1, 120. I'm thinking that this is going to be just another one. So 24 times 5. 4 times 5 is 20. 5 times 20 is 10, plus 2 is 12, so that goes here. Or 5 times 20 is 100, so that's 12. Yes, 120. Perfect, so that's 5 here. So B equals 45. Now 45 what? 45 feet. Find the length of the garden. We worked with square feet. We worked with linear feet. So this B equals 45 feet. Answer the question right there. Solving the problem. And how could you check this? Multiplying 45 by 24 to get 1,080. And you would know for sure you were correct. Now, on top of rectangles, we can also find the area of a parallelogram in the exact same way. If you can picture, if I cut straight down on this parallelogram, I would be left with this triangle, right? And this triangle, if I removed it, it would fit perfectly right here, leaving me with a rectangle. This is why the areas are the same, but we'll work on that more in class. So the area for finding a parallelogram is exactly the same. It's area equals base times height. So if I were to find the area of this parallelogram, I would have to look for the base and I would have to look for the height. The most common error that students make is choosing this right here for the height. But recall, it was very important a few boards ago, that the height of a polygon is always perpendicular to the base, meaning it comes straight down and it makes a right angle with the base. I am comfortable saying that the base is 6 2/3 centimeters, but the height is not 5 centimeters because this side of the parallelogram is not perpendicular to the base. 3 1/3 is the distance between the top of the parallelogram and the bottom of the parallelogram. It's a straight linear distance, and that is 3 1/3 centimeters, so that is the height. Okay? So if I'm finding the area, I will say A equals B times H. So area equals 6 2/3 times 3 1/3. 6 2/3, that's 18, 19, 20 thirds times 9 10 thirds. correct? Yes. So that's going to give me 200 ninths. Now 200 ninths centimeters squared doesn't really sound very friendly, so I'm going to do a quick long division problem to turn this back into a mixed number. 200 divided by 9. 9 goes into 20 twice, that's 18. 2 left over. It's going to be 22 and 2 ninths. 22 and 2 ninths centimeters squared is the area of this parallelogram. The last thing that I want to mention in this lecture is unit conversions, because sometimes story problems are written with the intention of misleading you, and I don't want this to happen. So I'm telling you to be very skeptical of units, meaning be very critical of the problems that are written for you, because if they give you yards and they ask for feet, like is what happens here, you could very quickly get a wrong answer, make a wrong answer choice, put something incorrect. So be careful. Bridget and Mark are building a rectangular patio measuring 9 yards by 7 yards. How many square feet of tile will they need? So I drew this patio. It is 7 yards by 9 yards, but it asks for square feet. So it's important to know the conversion between feet and yards. So 1 yard equals 3 feet. So I'm going to change these numbers to feet so I can find square feet. 9 yards is going to equal 27 feet, and 7 yards is going to equal 21 feet. So now I know that if I'm going to find the area, I need to multiply the base length by the height length, and I'm going to use feet so I can answer appropriately. So the area here is going to be 27 times 21. If I do my quick multiplication, I have 7, 2, 14, and 5. 7, 6, 5. So A equals 567 feet squared. Always, always go back and check. Now I know I'm working with feet here, so I labeled it correctly, but always go back and make sure you answer what is asked for. How many square feet? Well, 567 square feet. And that is the answer to the problem.